this is lecture number 23B. Okay. So, we are actually done with chapter 6. Yeah. So, this is chapter, you can say 6, 7. Yeah. Okay. So, 6 we almost done, because again here also chapter 6, 7, 8 we have to basically you cannot separate them out from each other. So, all the 3 basically should be studied together. So, whatever you are studying chapter 6 and chapter 7 will be required in chapter 8. So, basically this chapter 6 and chapter 6 we first found out the strong form for 2D heat transfer problem, and which was given by like this: divergence of Q is a flux minus S equal to 0. And then we found out the weak formulation. So, weak form, and we found out like this. So, we had the W Q dot N, okay, and which is to be integrated over the entire boundary minus gradient of W dot Q d omega, okay, and then we have minus W times S d omega, and everything equal to 0. So, you can see here that all of them are a scalar quantity. So, Q dot N is a scalar, W is a scalar, so everything is scalar. Here also this is a vector, this is vector, vector dot vector is a scalar. Here also W is a scalar, S is also a scalar. Hence, it makes sense basically. So, a scalar minus a scalar equal to 0. So, this is a weak formulation, and now next is we have to actually derive basically the we have to proceed further. Okay. So, this is from here we are going to find out like what exactly meaning of this one. So, finally, we have to convert that into what? Into this kind of equation, K times U is equal to F. That we have to do, yeah, which we call it finite element analysis. So, now Q has the Q has the T, right. So, where we know that Q is nothing but minus K gradient of T, yeah. So, this is what the Q is, and this is of course, this one is for isotropic. So, we are studying isotropic only, yeah. So, for others also we can do, but we will be taking up the isotropic case only. Okay. So, this you know that means the T term is there here, and we have to assume some test function for T, which T is a function of the x y basically. So, this is 2 dimensions. So, x y come into picture. So, T is not just a function of x, but also function of y. So, T x y. So, we have to assume T the test function, then this is W weight function also will be 2 dimensional now, and that is the only difference. As you also know that our test function has to be also based on the finite element method, meaning that this will be based on some kind of element. Okay. So, 2D element. Okay. So, the easiest you can think about will be something like this. So, you have some kind of rectangular system, right. So, something like this. This is the easiest one, where you will have, let us say, this and this. So, you have x here varying y like this one, and you will have minus L over, so a and b probably. So, you have minus a over 2, a over 2, yeah, comma, you have minus b over 2, right. So, minus b over 2 here, this can be a over 2 plus b over 2 minus a over 2 b over 2. So, these are the 4 corners, yeah, and the problem could be something like, let us say you want to solve a problem like this, the big problem, this one, and then you can divide into elements, something like this one, yeah, and then you can solve. So, basically the idea is that we are taking one of these, yeah, and one of these is looks like this one. If that is the case, then we can formulate T within every element as a function of temperature at this node. So, we can define node 1, node 2, node 3, node 4, and accordingly you will have functions. This is T1 here, T2 here, T3, T4. So, the T now will have x y will be given as, we can say, we have a shape functions, and we will have a summation of ni x y times T I. Same as in case of 1D, we extend the same thing here, that T will be a function of the nodal temperature, yeah, and also function of x y, and nodal temperature comes from this T I, and the function x y comes from this shape function, where I equal to 1 to 4, because there are 4 nodes. So, you can say 2D element, this is 4 noded rectangular element. This is the easiest one, and that is what we took, yeah. So, we will see at more complex one. Okay. So, now if that is the case, and we are saying that this element looks like this one, then how will this Ni be look like? And you know that is the property of n will be n1 will be 1 at node 1 and will be equal to 0 at nodes 2, 3, 4. You know that, right? So, in general you can say Ni equal to 1 at I equal to, so Ni equal to, so you can say this one is Kronecker delta, you can say this is Ij. Yeah. So, where I, you can say like this, delta Ij, not like this one. So, I is the ith, okay, maybe we do not write this way, So, okay. So, what we mean is basically there are 4 n's shape functions, n, and then this one is like this one. So, the n1 will be 1 here and 0 here and 0 here, here, here. Similarly, n2 will be 1 here and other places it will be 0, 0, right. So, basically if I is n I will be equal to 1 or 0. Say n I will be equal to 1 at ith node, okay, and will be 0 at other nodes. Okay, that is what it means. Okay, now what kind of function it can be? Yeah, so the simplest one, we can have what we call it bilinear element also we can say, meaning that we can write this like that we have defined something like this. So, we have like this one, distance from here to here is b over 2, from here sorry, a over 2, and then again from here to here you have b over 2, and here to b over 2. Yeah. Okay. So, now look at let us build n1. So, n1 x y will be equal to, now we know that n1, so this is 1 2 3 4 1 2 3 4, at n1 we have value equal to 1, others equal to 0. So, we can do like this one. So, all other places this is going to be 0. So, roots are at this, and how will you find out? So, we can have, think of 2 lines. Yeah. So, this basically the on this line everything will be 0, this line everything will be 0. So, all the 3 nodes are taken care of. So, what is the equation of this? Equation of this one. So, that means we can write is that the line, this equation, this one is nothing but y equal to. So, we can write here this is nothing but y equal to b over 2. This is what this line was, right. So, we can write y minus b over 2, then we write the equation of this line. The equation of this line is x equal to a over 2. So, this is nothing but x equal to a over 2. So, if you multiply by x minus a over 2, then automatically what we see, if you look at this one. So, if you have y minus b over 2, automatically both of them the value of n at both these points will be 0. When you also write x minus a over 2, that means this and this both will be 0. So, this is already 0. So, that means all nodes on these lines plus these lines will be all 0. That is why it tells. Yeah. Okay. So, now including them will guarantee that the value of n1 at this line and this line will be 0. So, the origin is here. Yeah. Okay. And the value of n1 has to be 1 at this point, okay, and the value here, this one is what? This one is this one is nothing but minus a over 2 minus b over 2. So put that value. So n1 there will be some value alpha. So n1 minus a over 2 minus b over 2 will be equal to alpha, yeah, and we have x is equal to minus a over 2, so will be equal to minus a, and b equal to y equal to minus b over 2. So you write here, so we get minus a and minus b, so we get alpha a b. Yeah, it has to be equal to 1, so we get alpha equal to 1 over a b. So basically what it tells you that n1 x y is equal to 1 over a b, and then x minus a over 2 and y minus b over 2. So this is what the first shape function is. Accordingly, you can find out all others. The second shape function, this n2 xy will be equal to, so now n2 here, okay, so we can draw it here. So how the n2 looks like? N2 will look like something like this. So 1 2 3 and 4, yeah, so this is here, this is 0, and we have equation, this one v is y equal to minus b over 2, this one is y equal to b over 2, here x equal to minus a over 2, here x equal to a over 2. Yeah, so these are the equation of these lines I wrote. So you can find out n2 has to 0 at this, meaning that has to 0 at this line and this line, meaning that 0 at y equal to b over 2, 0 at x equal to a minus a. So we can write this equal to beta times x plus a over 2 and y minus b over 2. Yeah, okay, and such that n2 and this at this point, and this point is what? This point is x equal to a over 2 and y equal to minus b over 2. So a over 2 minus b over 2 will be equal to beta x over x equal to a over 2 is a, so multiplied by a and multiplied by minus b equal to 1, and that tells us that beta equal to minus 1 over ab, and we get n2 xy equal to minus a b x plus a over 2 y minus b over 2. So this is what we got n2. Similarly you can we can find n3. So n3 xy will be in similar fashion ab, and then we will have x plus a over 2 x plus b over 2, so that at this one it will be 0 because you will put sorry, here it will be y. Okay, so you put y equal to minus b over 2. So, this will be 0 here, here you will be x equal to minus a over 2. So, this will be 0, yeah, and if you put here, then this will be a, this will be b. So, you get 1. So, this is how it is, and similarly you can also find out n4, yeah. So, let us write n4 here, okay. So, we can also find out n4 x y, which will look like something like this one, but this will be plus, this will be minus. So, minus a over a b x minus a over 2 multiplied by y plus b over 2. You can check it. So, 4, so x equal to a over 2, if you put a over 2, this becomes 0. So, n4 becomes 0 on this line. Regarding this one, if you put y equal to minus b over 2, so this becomes 0, yeah. So if you put x equal to minus a over 2, so this minus becomes minus a. If you put y equal to b over 2, you becomes b, so minus a multiplies b, so minus ab, so hence you get that. Okay, so basically this is how it works, yeah. So you have got all n1, n2, n3, n4, and hence you can write t as a function of, so t you can write like this one, where n1, n2, n3, n4, you know Ti is the, so Ti nodal temperature, yeah, and hence you will be able to find out the temperature, right. So, you have T equal to summation I equal to 1 to 4 Ni xy multiplied by Ti, okay. So, now the gradient of that, so this T and the, if you want to find out Q, because we have to write Q there. So, if you write Q, Q will be equal to the, before Q also this is what the test function is, test function. The weight function also you can write at W xy will be equal to I equal to 1 to 4 Ni xy Wi. So, you can also write like this one. Now, in the equation you have Q, right. So, we have like written Q like this. So, we have W Q written like this one. So, for since we want to convert that into a matrix system, so it is better to write the weak formulation as the matrix system, and so basically the weak formulation which is which says that this is omega q wq dot n, this is this, yeah, and then minus omega w dot q d omega minus w s d omega equal to 0. So, equivalent we can also write this one in terms of the matrix form, so that we will have easier to calculate. Yeah. So, we have in a vector form. So, weak formulation in matrix form, and so Q q we wrote as q, we said like this one, that means qx and qy, this is what the meaning of that. So, and n, so we have like n tilde is nx and ny, okay. And and then we have delta, so these are all equivalent, yeah. So we have delta tilde, which is meaning that del over del x and del over del y, this is what the meaning is, okay. So we can use that and we can find out that the first one will be simply we multiply w is a function, this is a scalar function, so we can just write w. So write it here. So the weak formulation will look like, so this one is again on the boundary, okay, and this is gamma, then we have w, so write w, this is the weak formulations, we write like that. We will not change into w1 times n1 yet, we are just writing the weak form itself. So w, the next thing is q dot n, so here we can write as q, we have like this one, so we write q tilde t times n tilde, okay. So this is basically this tells us this becomes q vector q dot n vector, that is what that is, and this is integrated over the whole boundary, okay, minus then whole domain, and then we have del w, okay. So del w, so basically here we have to write del w means like this, so let us look here. So we have del w dot this one, okay. So we have to write del, that means del w over del x, del w over del y basically, and then after that we are going to multiply it by this one, okay. So that means here we will write like this, so del w del tilde here, so that really means we have on this form 2 times 1 times form, but we have to write there is a dot, so here you get transpose and then q, yeah. So then you have q, so we write here q tilde, yeah. So d omega, yeah. So okay, so that we have a scalar here, so this is becomes, you write w here, so this becomes 2 times 2 by 1, so this is 2 by 1, if your transpose becomes 1 by 2, this is 2 by 1, so 1 by 2 multiplied by 2 by 1, so we get a scalar value here, done, and then we get minus w times s, so we can write here only minus w times s d omega equal to 0. So all vector has been taken out, what we have in all matrix form now, yeah. So now we can easily replace some of these values. So if you look at this one, we can also write this as w, or t, we can also write this one as n matrix multiplied by, so we can write as n1, n2. So, maybe we write the next page, probably it's easier. Okay, so let us do the next one. Next one, we want to put the value of q and all those t now. You can put value of t now. So, how is q and t related? So, we know that q vector, this q is nothing but, so q, we know that q is equal to minus k this, right. So, this is in vector form, we can write in matrix form basically. So, matrix form, this will be simply q tilde, meaning that this one is equal to, right, minus k, and then we have del tilde, which one is like this one, and then multiplied by t. So that we have qx equal to minus k dt over dx and qy equal to minus k dt over dy. Yeah, so this was still. So this also we can put it here. Okay, so if you put it here, so you will automatically get some values there. So from here we get, let me write in red now. So, we have close integral over whole gamma w, and then q we have to write this. So, we have minus k del tilde t transpose n tilde this minus omega, and then we have del tilde w transpose, and then we have minus k del tilde t d omega. Yeah. Okay, and then we have this term. Okay, so we can write minus, we write as very small, so minus omega ws d omega. Yeah. Okay, so whole thing equal to 0. So what we find now, here q term is eliminated. We have only either w and t, yeah, and the value of w and t we have here. So we can put those value directly there, and we can find out the actual the whole equation we can convert. Okay, so in general we can, in fact, no need to actually convert, no need to have kind of element in mind. We can still general purpose we can derive it. So we can assume, okay, assume for any kind of element we will have n I x y, not n I x y, but t, we have t x y is equal to n I x y t I, and where I equal to 1 to n. In general we can make a statement like this one. For the current one, n is equal to 4. Okay, so we give the one example. Similarly, w x y we can write it as I equal to 1 to n, and n I x y w I. Okay. Okay, so you can also write this is equal to t x y is equal to n matrix, okay, n matrix multiplied by t. Yeah. Okay, so where where T is where you can say where n is equal to nothing but n1 sorry n1 n2 so on till nn, yeah, and T will be this is n will be like a transpose of that, like this, okay, and T will be equal to T1 T2 T1 T2 so on to Tn, transpose of that, yeah, and similarly the W x y is given by this n matrix multiplied by the big W matrix, and where you can say this big W is given by, yeah, so this we are writing as this is given by W1 W2 to Wn, okay, so this is transpose of that, yeah. Okay, if that is the case, we can now put these values value of T and W, means this is the test function, this is the weight function, right. So this is the not to forget, this is our test function and this is our weight function, and we will put those values to the to this weak formulation, and accordingly we can find out what that is. So what you see here is T, so we have W minus K, and then T instead of T we will have n multiplied by T, so sorry the T n multiplied by this vector T, and so on. So we can put those value there and we can see what is the meaning of that. So let's put that. So our weak function becomes what? So first term is this, and then we have W. Okay, so we have W, so W is given by n times weight. Okay, so here n times weight, so just write that. So we have n, just write like this, times weight, okay, done. And then the next is minus k, and here the gradient vector, okay. So del tilde and then T is nothing but n times T, where T is the matrix now. So minus k del T transpose, minus k del T transpose. So we have minus k del tilde and then T. So basically this is tilde here. So T is nothing but we have n vector in matrix times not W but T, okay, T and transpose of that, okay. Okay, so we have like this one. Okay, so one thing more here, since this will have the boundary conditions here basically. So actually we don't have to add add n values here, like I don't have to put those n values. So since we have seen that this will have either either the W will be equal to 0 or Q will be prescribed. So we can directly put the values here. Yeah. So what I mean to say is here probably here we don't need to actually write in this form, because this will either we define q or w. So, what is the meaning of that is this one where we are applying this, no need to actually write like that, because it will never, n values will never be used. So, okay, so basically, so actually I should not have written this one. So, let's okay, so I am not deleting this one, I purposely putting it like this one, so we don't have to. So, we have this, and then we have del w, and then we have q dot n, yeah. So, q dot n d. Okay, so here the boundary condition will be imposed. So, we will impose the boundary condition, Okay, so this will as I explained in the last video lecture, this will have two types, either t is given. So, when t is given, this w will be 0 here. So, basically this entire thing will be equal to this q, and where q is given, that we will get. So, this will be equal to this will reduce to this, and then it will be q dot w dot q n d, this one, and but this one is given at this one. So, we can write this is equal to simply this q w times q naught d naught. Okay, so this value is given, this is a natural boundary condition, Okay, so we have taken care of the first part of the weak formulation. So, meaning that this value will be given, the whole thing will be given at some points where w will not be equal to 0. For other points w will be given. Now, so yeah. Okay, so let us say given points are natural boundary condition, which is given like this one. So, actually we have to put value of w here, yeah. So, we can put is equal to and w is nothing but n vector multiplied by w, n multiplied by w vector, and then q naught d. So, where q naught is given, yeah, this is prescribed at this boundary, on this boundary. Okay. Okay, so which will be equal to, we can also write is equal to gamma q, and we will have w transpose and n transpose, and then you have q naught d. So, the first part of the weak formulation we write here. So, this we have taken care of, where this means which came from the w q dot n. Okay. Now, this part, so here what we will need the second part. So, let us call this one is part 1, this is 2 and 3. So, let us say this is 1 and this one is number, okay, this is 2 and this is 3. Okay, so part 1 we are doing here. Okay, so we have done that. Now, part 2. Okay, so part 2. So path 2 is has of this form. So 0 this integrated over omega, and we have del w, right. So we have the del tilde w, and then we have this transpose, and then we have del tilde k. So we will have k here. Okay. So let's see here. So you can see here we have minus here. So minus this is k term. So basically this k term we can take it out. So we have minus plus, and we are assuming isotropic. So otherwise, if not isotropic, instead of k we can write d here basically. Yeah, so d, which will not be the d for anisotropic material. So in that case you cannot take it out. Okay, so what we can do here is minus plus. Okay, so the second term becomes basically plus because of this minus. Okay, so we have just this transpose multiplied by this, where k will be outside that. So we can write like this. So this t, okay, and then we have k, we can write k here, then d omega like this one is equal to, we can now put the value of this. So we have k delta tilde, and then we have n times w transpose, and then we have del tilde n times w d omega is equal to, now we have a transpose here, so we can accordingly we can see. Now delta, so this will be 1, this delta you can also see that how it is going to work. So this delta is 1 over 1 by 2 by 1, this n is 1 by n, and w will be n by 1. So you get total 2 by 1, but transpose becomes 1 by 2. So similarly here you have 2 by 1, n 1 by n, this one is n by 1. Yeah, okay. So when you take transpose, then what happens? So is equal to, we will have this k, and then we are going to have a k, and then w transpose delta n transpose, okay, and then we are going to have the delta n, okay, here we should have t, not n. Okay, so because we are talking about the t here, so we get t t dm. omega okay, and will be equal to k omega, we can have w gone out, and this you can call a B matrix basically. Yeah, so you can say B transpose and then another B here, okay, and d omega, and here we have a temperature. Okay, so this is what we get. This is a kind of not kind of this is what it gives you the stiffness matrix, this one, where B matrix is equal to del times n, yeah, del times n. Basically that really means that where del is del over del x, del over del y, and n is n1, n2 to nn. So what you get basically is first this applies to this, then secondly this applies to that. Yeah. So this, then this, then this. So what the meaning is equal to del n1 over del x, del n2 over del x, so on, del n over del x, and here it will be del n1 n2 over del x, del not n2, n1 only, over del y, del n2 over del y, and so on, del nn over del y. So this is what the B is. Yeah, so here what this one is, this is the K matrix. So basically the big K you will write is as, so big K matrix K you will write it as small k, and then B transpose B d omega. This is what the big K matrix. Okay, this kind of formulation we also had in 1D. So from there we remember b to the power t b. So we have like this. Next is number 3. So we have number 3. Okay, so number 3 we have simply we have this minus omega ws d omega, and we know that w we wrote it as minus, we have w we wrote is n, and then we had w, then s d omega, we can write it as minus w transpose n transpose s d omega. Why we did that? So that we take w transpose out of this. So we have been doing for all of them. For this also we did, because we want to get rid of this w as per the standard practice. Okay, so this is what we get. Okay, and so basically the finally this goes to the force. Yeah, so this will what it will make the force term. Yeah, so finally we have this multiplied by this one. Then for the second term we are getting this multiplied by the whole term multiplied by t. The first term you have again wt, which goes out like this one. Yeah, So we can write in all the cases, we can write this W2 we can make common and we can write like that. So how do you get? We get WT. So we can write like this. All together, okay, all together we get WT, and then okay, the second term first we are writing. So we have K B T B d omega, okay, equal to, then we have gamma q multiplied by n nt n nt. Okay, so let's look at that. Nt q naught probably. So we have nt q naught. That's it. Nt, then q naught, which is given, yeah, okay, or we call it q bar. Actually q naught is nothing but q bar, because you had q dot n. So yeah, so q bar, so q naught and d this, and then we have the first term. So let's look at the first term. First term is, okay, first term we wrote, okay, the last term, sorry. So the last term, so it will be minus the the first term is positive number, so we write a minus number here, and then it will be plus, okay, because this will go to the other side. So we have plus here, and then we have this is for omega n transpose s d omega, this one, all this equal to 0. So everything will be equal, no sorry, so this equal to this anyway, not 0 but this equal to. So this W arbitrary, hence we get this equal to simply this one. So our equation becomes simply, okay, I think something we missed here, the t term has to be there, so multiplied by t here, okay. So or since W is arbitrary, okay, so we get this equation. So this is omega and k b t b d omega is equal to minus no, so this is q, and then we have to write n t q naught, where q naught equal to q bar basically, yeah, equal to q dot n given, yeah. So this is q dot n only. So this is q bar, so means a heat loss, okay. So this is the heat loss, remember that, heat loss, hence we have negative value here, automatically we get the negative value. So q naught d gamma plus, okay, so let's write, okay, plus NTS D. So, or you can, or you write or K times, sorry, we have to write T here, we forget this. Okay, so K times T equal to F. So, T is basically U, right. So, equal to F, where K is equal to this, T is here, F equal to this, F that contribution coming from the heat source, contribution coming from the boundary as well, right. So, a contribution also comes from the boundary. So, heat loss, hence minus here, the heat gain, hence heat plus, this is for the whole domain, this is body force, this is kind of traction, right. Okay, so this force has these two, yeah, where K, this one is K, the whole thing is K, this is T, like this one. Okay, so this we have discretized basically, and we have got this one. Now things remain that what details, like what is the value of B, you obtain depending on N and all, right. So, that is what it is.